Hello students, welcome back to your math classes. How are you all? I hope you all are doing well. So students, welcome back and I hope you have practicing enough questions on those particular area where you're facing problems in previous chapters. Okay. Now we have a new chapter which is square and square root. Square means when we multiply a particular number itself, okay, by 2 times, and square roots when we have to find out those numbers. Okay, we multiplying this number by 2 times, so how can we have to find their square roots? Many mathematical operations have an inverse or opposite operations. You have learned that subtraction is the inverse of addition and division is the inverse of multiplication. We already know that. So squaring, which you learned about in the lesson on exponents in the earlier classes, has an inverse too called finding the square root. First we multiply those numbers and then we are finding, okay, when we multiply this number, so how we get that number which we have to multiply 2 times to get this number. Okay, remember the square of the number is the product of the numbers with itself. The product thus obtained, it's called square number or a perfect square, and the number itself, it's called a square root. So of the squares to obtain in this chapter, you shall study a pattern of square numbers which will enable you to determine whether a given number is perfect square or not. So this will also help you in understanding simple methods for finding squares of 2 and 3 digits numbers. You shall also study various methods of finding square roots of square numbers and finding approximate square roots of numbers which are not perfect square. So first we start square numbers. So 2 raised to the power 2. If I am talking in a language of my previous chapter which is exponent, so it means 2 raised to the power 2. It means we have to multiply 2 twice. So square means we have to multiply a number twice. So 2 multiplied by 2 is 4. 5 multiplied by 5 is 25. 9 multiplied by 9 is 81. 6 minus 6 raised to the power 2 means minus 6 multiplied by minus 6, which is 36. So note that square of number is always non-negative because we are multiplying our negative number twice, which means we are removing this minus sign. If a is the number, then square of a is written as a raised to the power 2 and it's equal to a multiplied by a. If the square of natural number m is n is m raised to the power 2 is equal to n, then n is called the perfect square or square number. In other words, a natural number is called a perfect square or a square number if it's the square or some natural number. So 4 is 2 multiplied by 2, 2 raised to power 2. 9 is 3 multiplied by 3, 3 raised to the power 2. So same way we are mentioning it. So the numbers 4, 9, 15 and 25 are perfect squares. Perfect square can be represented geometrically with the help of dots making a square as shown below. So this 1, this 4, then 9, then 16. So we can simply understand these are the perfect square numbers we have. Now to check whether a given natural number is a perfect square or not. So write the prime factorization of the given number. Make pairs of equal prime factors. See if some factor is left over or not. If no factor is left over from the pairing, then the given number is a perfect square. Otherwise, it is not a perfect square. So we already learnt about the prime factorization. So while we doing prime factorization, if all the numbers having in pairs, it means that number is a perfect square number. If we remove any number which is not in pair, it means it is not a perfect square number. Next, check whether 144 is a perfect square or not. So first we have to take the prime factorization for the 144. 2, 7, 2, 2, 3, 6, 2, 1, 8, 2, 9, 3, 3, 3. Now what we have to do, we have to make pair of these numbers together. So this is in pair, pair and pair. It means it is a example of perfect square because all numbers have their pair. So 2 multiplied by 2 multiplied by 3. So 2 2 is a 4, 4 3 is a 12. So this is the square root of 12. Okay. Now show that 2025 is a perfect square. So this is now your task. You have to repeat the same concept and same method which I am following over here while I am solving the example number 1, and then you have to find out okay, these numbers are in pair or not. If these numbers are pair, it means it is a square number, and if these numbers are not in pair, so what does mean by it? It means it is not a perfect square. So if you solve this question, so what will we get? Okay, fine, this is a perfect square. Now Properties of square numbers. So the first property, square numbers exhibit several interesting properties and patterns. These properties help in checking whether a given number is a square number or not. Before you study this property, observe the table which displays the squares of the first 30 natural numbers. So we have the first 30 natural numbers. Most of the cases what students do, they just learn these numbers. You can do both the things. You can learn these square numbers. It will be easy for you to find out the you have to find out the square root of that number. Otherwise, you can simply understand the concept how we have to find the square root. So, do you observe some pattern in the square numbers? You can check your observations from the following properties of square numbers. No square numbers ends in 2, 3, 7 or 8. It means if you see any last digit number as 2, 3, 7, 8. So you have to self-understood this that these numbers are not perfect square. A glance at the above table shows that the square numbers end in 0, 1, 4, 5, 6 or 9. You can also see that if n is equal to m raised to the power 2, then the digit at unit place in n is the unit digit of the square of the digit at units place in m. Thus we have. It implies that a number having 2, 3, 7 or 8 at units place never a perfect square. So always keep in your mind, students, the numbers which ends with these numbers now, those are not your perfect squares. Okay. Next, the number of zeros at the end of a square number is always even. If a number ends in 0, then it is a square ends in 00. So if you have 0, it is a square number, but what you have to keep in mind, the numbers of 0 should be in even. Here 2, 2, 4, 4. It means it is a perfect square. Next, in fact, the number of zeros at the end of a square number is twice the number of 0 at the end of the given number. Thus, if number ends in odd number of zeros, then it is not a square number. For example, 110, 1670, 9000 are not square numbers because we have zeros in odd numbers. And we only take square numbers when we have zeros in even numbers. Okay. So square of even numbers are always even numbers and squares of odd numbers are always odd numbers. The squares of natural numbers other than 1 is either a multiple of 3 exceeds a multiple of 3 by 1. In other words, a perfect square except 1 leaves remainder 0 or 1 on division by 3. So if I have a perfect square rather than 1 and we divided it with 3, so what we get at as remainder? We will get 0 or 1. So 4 divided by 3, we will get 1. 9 divided by 3, we will get 3. 4, it means ये आपको बताया हुआ है कि remainder, what we have the remainder while we divide these numbers with the 3. So 4, 1, 9, 0, 16, 1, 25, 1, 36, 0. It means when we have a perfect square number, it means if we have divided this number with 3, so what we get at the as in remainder 0 or 1. Thus, if number leaves remainder 2 or division by 3, then it is not a square number. Always keep in mind, if you have a number and you divide it with the 3 and you get the remainder 2 rather than 0 or 1, it means it is not a square number. The square of natural number other than 1 is either a multiple of 4 or exceed a multiple of 4 by 1. In other words, a square number leaves remainder 0 or 1 on divisible by 1. So the same thing we am repeating in the while we take the 3, the same thing we have while we taking the 4. So if n is a square number, then 2n can never be a square number. In other words, you cannot find natural number a and b such that a square is equal to 2b square. You can verify this from the table containing squares numbers from 1 to 30. So 4, it is not a square number. So if you have n and 2n means double of n. So 4 ka double is 8, 9 double is 18, 16 double is 32. And you see in all the cases, if we have the number n and we take the double of that number, it will not a square number of 2n. Okay. So the difference between the squares of two consecutive natural numbers is equal to the sum of the numbers. For every natural number, n plus 1 whole square minus n square is equal to n plus 1 plus n plus 1 plus n. So 7 square minus 6 square is 49 minus 36, which is equal to 13. 13 is equal to 7 plus 1, which is equal to like this. So 7 square minus 6 square is equal to 7 plus 6. So you can simply say 18 square minus 17 square, at the end 18 plus 17. 24 is to the power 2, 23 square 576, 529, you will get 47, and 47 means 24 plus 23. So and is your same result. The square of natural number n is equal to the sum of first and odd numbers. The square of natural number n is equal to the sum of n odd numbers. So when we take 2, the 2 odd numbers, 1 plus 3 is 4. 3, first 3 odd numbers, 1 plus 3 plus 5 is 9. 4, first 4 odd numbers, 1 plus 3 plus 5 plus 7, 16. So while you adding first 2 odd numbers, you will get 2 square. While you add 3 first odd numbers, you will get 3 square. Okay, and so on. So in each case, n square is equal to sum of first n odd numbers. Thus, if a natural number cannot be expressed as the sum of successive odd natural numbers starting with 1, then it is not a perfect square. So, if your natural numbers cannot express as sum of successive, if we add 1 over there, so it means it is not a perfect square. Some interesting patterns of square numbers. The sum of two consecutive triangular numbers is a square number. Recall that triangular numbers are the numbers whose dot patterns can be arranged as triangles shown below: 1, 3, 6, 10 and 15. The triangular number 1, 3, 6, 10, 15. Observe some two consecutive triangular numbers. 1 plus 3 is 4. 3 plus 6 is 9. 6 plus 10 is 16. 10 plus 15 is 25. It means the sum of two triangular numbers is equal to a square number. So clearly in each case the sum is a square number. This can also be observed by combining dot patterns of two consecutive triangular numbers as shown below. So there are two and non-zero square numbers between two consecutive square numbers n square and n plus 1 whole square. It follows directly from the property of square numbers that you studied in the previous section for a natural number n. So what we understood now, if we take two triangular numbers and n, so we will get a square of square number, and we can take 3 patterns like this. If we make it, so we will get the same result. For example, between 1 square and 2 square, 1 and 4, they are known square numbers are 2 and 3. 2 is equal to 2 multiplied by 1. Okay? Now 2 square and 3 square, 4, 9. Numbers are 5, 6, 7, which means 4 is 2 multiplied by 2. The square of any odd natural number other than 1 can be expressed as the sum of two consecutive natural numbers. 3 square is 4 plus 5. Two consecutive numbers. 2 consecutive numbers, 25. 2 consecutive numbers, 25 plus 24 is 49. Thus, if n is an odd natural number, so n is always greater than 1, then n square is equal to n square minus 1 divided by 2 plus n square plus 1 divided by 2. The product of two consecutive odd even natural numbers is 1 less than the square of the even odd natural number between them. So 7 multiplied by 9 is 63. Okay. If I minus 8 square minus 1, I'll get this. Now 14 square minus 1 is this. 42 square minus 1 is this. You can simplify this. Some distinct patterns in square numbers. Square of some numbers exhibit interesting patterns. For example, considering square numbers 1, 11, 111. So 1 square is 1. Now 11 square. 1 plus 1 is 2. So 1, 2, 1. 1 plus 1 is 3. So 1, 2, 3, 2, 1. Then 4. 1, 2, 3, 4. What you have to do, how many numbers you have? Now after that you have to reverse your counting. Here 1, 1. 1, 2, 1. 1, 2, 3, 2, 1. 1, 2, 3, 4, 3, 2, 1. यहाँ पे 5 होगा तो 1, 2, 3, 4. Now reverse your counting. 4, 3, 2, 1. Now 6, 1, 2, 3, 4, 5, 6. Now reverse your counting. 5, 4, 3, 2, 1. So in that manner you can solve your questions. Okay. In each number on the RHS, you can observe the symmetric pattern of digits. Also, the sum of digits of every number on the RHS is a perfect square. So consider the following numbers. 7 square is 49. 67 square is 4, 4, 8, 9. 66. 7 square is this. So you can simply 49, then 6, 7 square, 40, 4, 4, 8, 9. In each number on the RHS, you can observe the symmetric pattern of digits. Also, the sum of digits of every number on the RHS is a perfect square. So we are explaining this thing over there. Now, observing the pattern shown by these square numbers, you can find 666, 666, 7 square is 5 times 6, 7 square, etc. So 15 square is 225, which means 1 multiplied by 2 multiplied by 100 plus 25. 25 square is 625, 2 multiplied by 3, 6 multiplied by 100 plus 25. 3 multi. So you can see, okay, if we have 1, what comes after 1 is 2. So 1 multiplied by 2 is 2, and that your suffix of it is always same. 2 multiplied by 3 is 6, 25. 3 multiplied by 4 is 12, 25 is same. 4 multiplied by 5 is 20, 25 is same. 5 multiplied by 6 is 30, 25 is same. In that manner, you have to solve it. The square of a number with 5 at unit place and m as the remaining number obtained after deleting units place is given by m multiply m plus 1 multiply by 100 plus 25. Now, Pythagorean triplet. Recall that a triplet ABC of three natural numbers A, B and C is called a Pythagorean triplet, which means if A square plus B square is equal to C. So 3 square plus 4 square is equal to 25, which is 5 square. 5 square plus 12 square is equal to 169, 3. If the sum of two numbers is equal to the third one, it means you have a Pythagorean triplet. Now, to write a Pythagorean triplet whose one member is 8, so we take 2n is equal to 8, n is equal to 4. Now, n square minus 1 is 3 square minus 4 square minus 1, which is 15. Second one is n square, which is 16 plus 1 is 17. So, these three are your Pythagorean triplet, 8, 15 and 17. Okay. Now, the following numbers are not perfect squares. Give reasons. Because these numbers are end with 2, 7, 5, 3 and 000. So, these are the reasons, because according to properties of square numbers, what we learned over there, if we have n digits, the last one's digit 2, 7, 5 and odd number 0, so it means it is not a perfect square. So, what will be the unit digit of the square of the following numbers? So, what will be the unit digit? 52. So, then 2 square is 4, 7 square is 49 and 49 end digit is 9. Then 5 square is 25, end digit is 5. Then 6 square is 36, end digit is 6. Determine whether square of the following numbers are even and odd. So, this is an odd number, so odd yoga. Okay. Then 952, so it is an even number, so even. Then 3718, 3718, it is an even number, so the square number is also a even. Without calculating the square, find. So, how can we calculate the? Then 81 square minus 80 square, n plus n square. So, 81 plus 80 is 161. 116 plus 115 is 231. How many natural numbers lie between these two numbers? So, how can we calculate? There are two n natural numbers between n square and n plus 1 square. Therefore, 2n, 15 multiplied by 2, 30 and n plus 1 square, which means 2 multiplied by 30. Next, between 78 square and 79 square is 2 multiplied by 70 is 156. Express 64 as the sum of 8 odd natural numbers. 64. So, how can we? So, we have to take first 8 odd numbers. 1, 2, 3, 4, 5, 6, 7, 8. 8 multiplied by 8 is 64. Express 17 square as the sum of two consecutive natural numbers. So, n square is equal to n square minus 1 by 2 plus n square plus 1 divided by 2. Therefore, 17 square minus 1 divided by 2, 7 square plus 1 divided by 2, which is 144 and 145. Write a Pythagorean triplet whose one member is 15. So, how can you represent it? 2m, m square minus 1, m square plus 1. So, 2m is 30. M square minus 1 is, so how m square 16 is equal to 4 square. So, m is 4, 2m is 8. M square 16 plus 1 is 17 and m square minus 1. So, 16 minus 1 is, so you have now 8 plus 15 plus 17. Okay. 8, 16 and 17. Using prime factorization, find which of the following members are perfect squares. So, first we take 324, 2, 1, 6, 2, 8, 1, 2, 3. 2 multiplied by 3, 6. 6 multiplied by 3, 18. So it is a perfect square. So in same way, you have to solve rest of the question. Show that each of the following is a square number. Also find the numbers whose square is the given number. So 676. It is a square number. So 247. This is a square number and the square root of this is 30. You can simply find out with the help of prime factorization. The following numbers are not perfect square. Give reasons: because it end with 3, because it end with 8, because it end with 2. And according to properties of square numbers, if the number at one's digit is these numbers, it means it is not a perfect square. Next, what will be the unit digit of the square of the following numbers? 8 multiplied by 8 is 64 and 64 unit digit is 4. This is your answer. 1 multiplied by 1, this is your answer. 6 multiplied by 36 and an answer is 6. 6 multiplied by 36, 36 and our answer is 6. Without using prime factorization, show that the following numbers are not perfect, are not square numbers. This is not a square number. This is not a square number and this is also not a square number. Determine whether squares of the following numbers are even or odd. Even because it is a even number, odd because it is a odd number, odd you can simply find out without calculating the squares. Fine. So what you have to do, 75 plus 74, you can get your answer. 70 70 140 and 140 plus 9 is 149. How many natural numbers lie between these? So how can you find out? First, 2n. So 2 multiplied by 13 is 26. In that way, you can simply find out. Express 81 as the sum of 9 odd numbers. So what you have to do, you have to take first 9 odd numbers. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13, 15, 17 and 19. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have to take first 9 na? So bus. Till 17 you will take and this is your answer. Express the following numbers as the sum of two consecutive numbers. So how can you express it? I already explained you in example. So you have to go through that example or simply solve this question. Write a Pythagorean triplet whose one member is 6. So I already explained you this also. If your 6 is this, so 2m is equal to 6. So m value is 3. 3 square plus 1 is 10. 3 square minus 1 is 9. So these are your Pythagorean triplet. Now 1 2 1, 1 0 2 0 1, 1 0 0 2 0 1, 1. How many zeros? 1 2 3, then 2 1 2 3 and then 1. So in that way you have to complete it. 1 square plus 2 square plus 2 square is equal to 3 square. 2 square plus 3 square plus 6 square is equal to 7. So I already explained you how you have to solve it. You can go through your examples and take it. And with that your exercises end here. So I hope students this exercise is clear to you. And you have any doubts, what you have to do, first you have to understand the examples first and then you have to come back to your exercises. Now I'll meet you in your next exercise with a new concept. Till that, keep learning, keep practicing questions and bye-bye.